This is MATHguide.com, and my name is Mark Karadimos. In this video, we're going to talk about counting problems. Specifically, we're going to address election problems. In our first section, we're going to talk about the tools, which are the formulas we use for counting. And then in the following three sections, we'll do a problem. So we'll do 3 problems. All right, let's get started. There are 2 formulas shown, and these 2 formulas are used extensively when dealing with counting problems. The first formula is called the combinations formula. The second formula is called the permutations formula. Now, it is important to use the correct formula for the right set of circumstances. So we use the combinations formula when order does not matter. We use the permutation formula when order does matter. In order to really flesh out the correct usage of these 2 formulas, you really have to walk through some examples. So in the next 3 sections, you'll see problems, and sometimes the combinations formula is used, and sometimes the permutations formula is used. Here's our first problem. Ms. Chalmers is supervising 15 of her students on a field trip. She wants to choose 3 students to assist her. And how many ways can this be done? All right, so we know that she has 15 students, and the fact that she has to choose 3 of them, it really doesn't matter in which order she chooses these students. When she chooses the first student, or if she had chosen that student second or third, it doesn't matter. All of those students are taking on the role of an assistant, and there doesn't seem to be any difference between the roles. At least that's how it's stated here, that there's no special role for each student. So it doesn't matter in which order she chooses these students. All right, in that case, we're going to take this as a combinations problem. So we're going to say she's got 15 students, and she's going to choose 3 of them. So we're going to plug this into a calculator and see what the answer is. There's 455 ways to do this. So let's go on to a second problem. Here's our second problem. The chess club wants to elect a president and vice president. If there are 15 members of the club, how many ways can these 2 positions be filled? Now, unlike our last problem where we're picking assistants and they all have the same role, here, these people who are choosing have special roles. Clearly, the role of president is different than the role of vice president, and that's true in every situation. So, if they had the same role, we wouldn't use special titles to declare their roles. Okay, so let's talk about how this is done. So, since the order in which we choose the first person president and the second person vice president matters, this is a permutation problem. So I'm going to use, 15 members, and I'm going to pluck out of those 15 2 people. And order matters because it's president, vice president. And again, you throw this into a calculator and it'll give us the answer. So there are 210 ways to do this. Okay, that's all there is to it. Let's go on to our third problem. Here's our third problem. So there are 256 members of a lodge. They will elect a president, vice president, and a treasurer. After the election, the elected officials will choose 10 cabinet members. And how many ways can this be done? Now, this is a tricky problem because there's 2 parts to it. Let's talk about how many ways there are to choose the president and vice president and treasurer. So now the order in which they choose those three positions matters, and each of those positions obviously carries a different role, so order matters. So we're going to use permutations. So if there's 256 members, and we're going to select 3 of them, in order matters, we use the permutation, and I throw this in a calculator, get an answer. So this is what comes out of the calculator. So it looks like there's over 16.5 million ways just to choose the president, vice president, treasurer. Now let's talk about after these 3 people get elected. It looks like they're then going to choose some cabinet members, and we're going to choose 10. So now what do you do with that? Now this is a little complicated because order does not matter here, because we're going to take 10 people and give them a role, and all their roles are going to be the same. All right, now what's tricky about this is, remember, out of the 256 people, 3 have now been chosen. So there's now 253 people that are left to choose these 10 cabinet positions. Okay, so out of the remaining pool of available people, which is 253 now, we're going to take 10 of them. I'm going to place this into a calculator and see what the number is going to be. So this is what the calculator gives me, which is millions, billions, trillions, quadrillions. A huge number. So we've now calculated the number of people, or ways we could choose the elected officials. This is the number of ways we then can choose the number of cabinet members after we have chosen the elected officials. So now if I want to find what is the total when I put them together, I'm going to use the fundamental accounting principle, which would say I would multiply these 2 remaining quantities, multiplying them together to figure out what they would be. All right, so let's take a look at this extremely large number. As you can see, there's many ways to choose all these representatives. So that's million, billion, trillion, quadrillion, quintillion, sextillion, septillion. So that's huge. If I put that in scientific notation, it would be, so that would be 4.1 times, of course roughly, 4.1 times 10 to the 24th. So we're talking about a huge, huge number of ways to select these representatives. So if you go back to MATHguide.com, you could see more interactive quizzes, instructional videos, and text-based lessons. Take care.